Good day. Today, our scientific inquiry takes us to the southern celestial hemisphere. We'll be conducting a rigorous examination of a small constellation that harbors some truly significant astrophysical phenomena. I'm referring to Musca, the fly. Now, despite its diminutive size, it is, for all intents and purposes, a natural laboratory, home to stellar volcanoes and even black holes. Let's begin our analysis. Here is the agenda for our analysis today. We will begin with the fundamental subject, the constellation Musca itself. From there, we'll proceed to its astrometry and visibility. Then, we will delve into the key astrophysical objects within its boundaries, followed by an examination of its nebulae and clusters. We will also touch upon its history, before concluding with a practical perspective for the observer.
So let's begin. Musca's position on the celestial sphere is immediately adjacent to one of the most recognizable asterisms in the southern sky, the Southern Cross. You see, this strategic location makes it an absolute goldmine for astrophysicists, packing a number of rare stellar types and enigmatic dark clouds into a very small patch of sky.
Now, if we examine the core data, we get a precise profile of our subject. It covers just under 140 square degrees, which, you'll notice, ranks it 77th in size, making it one of the smallest constellations. Its coordinates, the celestial equivalent of longitude and latitude, place it deep in the south. But don't let its small area deceive you. Under clear conditions, approximately 60 of its component stars are visible to the naked eye.
So, we have its celestial coordinates, but the critical question for any observer is, what do these numbers mean for us, here on the terrestrial sphere? Where must one be positioned to actually conduct an observation? Let's analyze its visibility conditions.
Musca is unequivocally a southern object. Let's visualize the Earth for a moment. If your location is anywhere south of the 14th parallel north, that's regions like South America, Australia, or Southern Africa, you'll have a complete and unobstructed view. Now, in the band between 14 and 26 degrees north, it will appear, but only just skimming the southern horizon. For any observer positioned north of that latitude, Musca is an unseen phenomenon, permanently hidden below the horizon.
And for those of you fortunate enough to be in the southern hemisphere, the optimal window for observation occurs during March and April. Around midnight local time, the constellation culminates. That is to say, it reaches its highest point in the sky. This is crucial for clear viewing as it lifts the object out of the atmospheric distortion and haze that lingers near the horizon. Now we proceed to the core of our study. Contained within this compact constellation are some of the most scientifically interesting objects in our galaxy. Let's begin our detailed analysis of the astrophysical jewels of Musca. First, we have Theta Muscae. This system contains a Wolf-Rayet star. I want you to visualize a stellar supervolcano. These are exceedingly rare, massive stars in their final, violent evolutionary stages. They're so energetic, they blast their outer layers into space via a tremendously powerful stellar wind. Theta Muscae provides us a perfect specimen of this cataclysmic process. Next, there's Nova Muscae 1991. Now, in 1991, astronomers observed a transient event, what appeared to be a new star. It was, in fact, a binary system, a standard star locked in a gravitational dance with a black hole. Picture this. The black hole's immense gravity siphons material from its companion. This material doesn't fall straight in. It forms a superheated, rapidly rotating accretion disk, which emits incredibly intense X-rays. By studying these emissions, scientists found some of the first direct evidence that black holes do, in fact, spin. And to give you a sense of the energetics involved here, let's consider the constellation's brightest star, Alpha Muscae. It's a blue-white subgiant, hotter and larger than our Sun, just beginning its evolution off the main sequence. Its luminosity is equivalent to 20,000 of our suns, making it a brilliant beacon that helps us navigate to the other phenomena in the region. We have examined the points of light, but what of the voids between them? Musca is also host to extensive clouds of interstellar dust and ancient stellar populations. You must understand, these dark regions are not empty space. They are simply so dense with cosmic dust that they completely obscure the light from stars behind them. Musca contains the southern part of the well-known Coal-Sack Nebula. Visually, it's like a great tear in the stellar fabric of the Milky Way, a dense cloud of dust blocking the light of countless stars. Nearby, we find the Dark Doodad Nebula, a unique filamentary structure that appears as a delicate, dark ribbon against a brilliant stellar backdrop. And yet, amidst this darkness, we find light. The globular clusters NGC 4833 and NGC 4372.
These are ancient cities of stars, each well over 10 billion years old. For a moment, let us step away from astrophysics and into the realm of history. The way this constellation acquired its name is a fascinating case study in exploration, cartographic error, and scientific consensus, a clear example of the human element within science. The naming process was, well, one of correction and elimination. It was first catalogued in 1598 as Apus, the bee. However, this created confusion with the adjacent constellation Apus, the bird of paradise. To resolve this ambiguity, in the 18th century, Nicolas-Louis de Lacaille renamed it Musca Australis, the southern fly. Much later, after a short-lived northern fly was abolished, the International Astronomical Union officially truncated the name to simply Musca in 1922. Now, while Musca lacks any connection to ancient mythology, 17th century cartographers created a kind of post-Renaissance mythology for it. On the celestial globes from that era, you can see the neighboring constellation Chameleon depicted with its tongue fully extended, perpetually attempting to catch the fly. It's a charming biological drama, a narrative written onto the star charts themselves. All right, let's synthesize this information. We've investigated the astrophysics and the history. Now, let's bring our focus back to practical application, how you, the observer, can locate Musca and appreciate its scientific significance firsthand. For those of you located in the southern hemisphere, the process is quite direct. First, identify the Southern Cross. It's your primary landmark. Immediately to its south, you will find a small pattern of 4 bright stars that form a distinct arrowhead or kite shape. That is Musca. I strongly recommend using even a basic pair of binoculars. The view is spectacular. It will resolve the stark contrast between the dense star fields and the profound darkness of the Coalsack Nebula. And so we conclude with this unique fact. Of the 88 officially recognized constellations, Musca stands alone. It is the only one named for an insect. It serves as a unique placeholder, a symbol that even the smallest of creatures has found a permanent place on the celestial sphere. Ultimately, our study of Musca reveals a fundamental truth about cosmology. Behind a simple, unassuming name lies evidence of colossal energy, the death throes of a Wolf-Rayet star, the immense gravitational power of a spinning black hole. And this leads us to a final question for reflection. If this wealth of physics is hidden within the tiny fly, how many similar treasures does the cosmos conceal, awaiting their moment of discovery?